is 4.1, day 3, focusing on how to find the arc length and using the formula along with degree, minutes, seconds measurement. Just go ahead and write the topic down. The definition of theta is used to represent an angle measure. You don't need to write that down. I would recommend you write this formula. You've used this in geometry. It's the measure of an arc length. So if we give you a central angle in radians and the radius, we can find the length of the arc. So I'm going to just draw a picture of it. You don't need to draw this picture. Let's say I give you an angle that looks like this, and then I give you a radius here. What we're looking for is how long this piece of that curved arc is, how long it is. So go ahead and write the formula down along with the pieces. Make sure you notice the angle, the central angle, has to be in radian measure. Use this formula. And then we'll have some examples to follow using that formula. All right, here's a couple examples. Let's start with the example on the left, example A. We give you a central angle of 120 degrees and a radius of 5. I'm just going to throw a length in there for that radius. Our radius will be 5 centimeters. So the central angle, if I graph that out, is a little bit more than 90 degrees, looks about there. So this would be my theta of 120 degrees. And what we want to do is find out how long that curve is. This is our unknown, which is our S, our arc length. We cannot use the formula quite yet. What do we have to do first? Why can we not use the formula? First, yes, correct. We have to convert that central angle to radian measure first. How do you convert 120 degrees to radians? Either use the formula that we gave you yesterday, or remember from the chart, by memorization, what 120 degrees is. Either way. So we'll do step 1 together. I'm going to use the formula just to practice it again. So number 1, we have to convert to radian measure. So to find the radian measure, that formula is 120 degrees is our given angle. And then what's going to go in that fraction? Pi over 180 degrees. So then what will cancel? The degrees. And then I can try and reduce the fraction down. What can I reduce 120 and 180 by? What factor? by 60. So I can divide 120 by 60 and I get 2. And I can divide 180 by 60 and I get 3. So then my central angle in radians is 2 pi over 3 radians. Now I have my theta. Now I'm set to use the formula for arc length. So S equals R times theta. So what's our R? 5, yep, 5 centimeters. And what's our theta? 2 pi over 3. And let's get this into decimal form. So you're going to need to use your calculator. And we have units going on in there, so we want to make sure we have the correct, proper units. So what is the arc length of that segment? What is it? 10.47, do we agree? Centimeters. All right, let's go to example B. Example B has a different central angle, and we'll call this radius 5 feet. So angle measured for pi over 2, where does that fall? What's the degree measure? It's very popular with our 90-degree measure. So here is what our angle will look like. This is our radius. Our theta is pi over 2. And it's already in radian measure, so we don't have to convert it. And what we want to do is find out how long this arc length is. That's our unknown. So I'm going to give you about a minute lead time to go ahead and find it yourself. What'd you plug in for R? 5 again. And now what's your angle? Pi over 2. So how long is this segment? What is it? 7.85 feet. Agree? Okay, good. Let's go to this one. Find the angle now given this figure. So we want to find the central angle. And this is the sector that we're working with. What are the two things they give us now? What are the two pieces? Yep. So here is my radius. This is my arc length. And we're going to substitute it into the formula to find the central angle. And And that central angle will be in radian measure. So let's substitute it in. What's going to go in for S? 6. What's going to go in for R? 8. What's going in for theta? Unknown. So what's the next step? Divide by 8. So 6 divided by 8, or theta equals 3/4 a radian. So 0.75 radians. This one I'm going to skip, but I just want to talk about. The difference with this example, that you don't need to write down, is you have to do 2 steps. What would you have to do first? It's asking you for that piece of this angle measure. So you'd have to first maybe find this first, right? Find theta 1 using the formula, and then subtract out from 2 pi to get theta 2. Understand that? You'd have to first use the formula to find this central angle, and then the leftover piece you subtract it from 2 pi, because that's the entire revolution. And this is what you'll be left with, is this angle measure. All right, I'm going to stop the recording. We'll go on to degrees, minutes, seconds next.